So thanks everyone for showing up. We have Cohen Bothmer from the University or International University of Applied Sciences in Germany, and he'll be talking about Skill Scanner, connecting and supporting employers, job seekers, and educational institutions with an AI-based recommendation system. So as kind of a coder myself, I'll be interested in looking at the algorithms and the output statistics that you use to make the recommendations. So I'm looking forward to the talk. It should be great. So I will mute and get off the phone, get off the picture, and it's all yours.
All right, thanks, Bruce. Like you said, I'm Koen Bothmer. I'm a master's student from IU, International University of Applied Sciences. And Tim, who's my professor, who was first scheduled to speak, he's unable to attend, so I'm standing in for him at reasonably short notice, so I might have to refer to my notes at some point, so please bear with me should that be the case. And like you said, a little bit more of a technical speech. I hope you like that kind of a speech. So anyway, I'm presenting our work with title Skill Scanner, connecting and supporting employers, job seekers, and educational institutions with an AI-based recommendation system. So let's begin with a quick outlook of what I will talk about today. I will start with the motivation, then I'll say a few words about related work, and after that, I will talk you through the natural language processing pipeline of our application Skill Scanner, which extracts, vectorizes, clusters, and compares skills. Next, I will demonstrate excerpts of Skill Scanner's reports about covered and missing skills in job postings, CVs or resumes, and learning curricula. Then I will talk about the feedback on Skill Scanner that we received in our survey. And finally, I will sum up and indicate possible future steps. So let's start with the motivation. Access to education is one of people's most important assets, and ensuring inclusive and equitable quality education is goal number 4 of United Nations Sustainable Development Goals. However, this goal should not only refer to general education, but also to specific education in the professional environment. The teaching offer must fit the demand of the job market. If people have the right education for the professional environment, they have a better chance to get jobs that allow them to have a good life. So let's have a closer look at on how this works. Because what we believe is employers, they communicate the demands of the job market in their job postings. Job seekers, on their part, communicate how well they fit these demands by their CV or resume. Educational institutions prepare students for the job market by preparing their learning curricula to the job market's demands. In this way, these 3 players involved interact with each other. And we believe that this interaction can be optimized, and in this way, a right education for the professional environment can be implemented by an AI-based recommendation system that connects and supports the 3 players, employers, job seekers, and educational institutions. This would lead to the greatest possible exchange of information, and it satisfies their needs. So I wanted to have a bit of a deeper look on these relationships, which also bring us to some of the related approaches described in literature. Please understand, when looking at all these interactions among employers, job seekers, and educational institutions, there is a lot of related work, so the references are only examples. Because usually, employers, job seekers, and educational institutions use AI in isolation from one another. So let us start with some examples from the employer's point of view. Employers want to automatically check which of their required skills are covered by an applicant's CVs, which is the find and select arrow right here. They also want to know which courses their employees can take to acquire missing skills. That means for upskilling, so the find and select arrow on this side. To achieve this, there's some related work. For example, for automatically ranking CVs, that's very helpful to employers, of course. And an example, Valiarca et al. 2014 ranked candidates for a job based on semantic matching of skills from LinkedIn profiles and skills from their job description, relying on a taxonomy of skills. Fernandez, Reyes, and Schinde, 2019, used word embeddings from Word2Vec to match CVs to jobs. And then we have Wang, Alouar, and Joubert in 2021. They combine a knowledge graph and Google's natural language processing model BERT to find suitable candidates in a corpus of CVs. And on the job seeker side, They want to know which skills from job postings are missing in their CV so they can fit to demand, and which study programs they can take to acquire missing skills so they can find and select an appropriate study program. For this, recommendation system for job seekers have been investigated, in example by Sitting et al. 2012, Alataibi 2012, and Hong et al. In 2013. Just like in the systems for employers, text data from social media profiles such as LinkedIn or Facebook is usually processed. Lee et al. 2016 have built a taxonomy of standardized skills, and they use semantic matching to measure the similarity in job descriptions and job seekers' profiles. In addition, from the educational point of view, educational institutions, they want to make sure the skills that are in their learning curricula, they fit to the demand of employers' needs, so they fit to the job market. And furthermore, they want to advise and attract the right students. Rouge, Kadel, and Halder, 2021, give an overview of recent publications on course recommendation. Most related work focuses on recommending courses to potential students. They report a growing popularity of data mining techniques in those systems. To cope with the challenges of abstraction levels and synonyms in the course material and students' documents, some researchers first cluster the content, which they can then compare. As mentioned, connecting and supporting all three players allows the greatest possible exchange of information. Consequently, we developed SkillScanner, an application which processes skills, so it extracts, vectorizes, clusters, and compares skills, more on that later, in job postings, CVs, and learning curricula. So here are a few examples of how skills are described in these documents. Our application is able to extract and process these skills so they can be compared, which makes it possible to analyze covered and missing skills. For this comparison, our application then outputs recommendations for employers, job seekers, and educational institutions based on skills that are present, but also skills that are missing and their importance to the job market. During the implementation of SkillScanner, we investigated several natural language processing techniques to extract, vectorize, cluster, and compare skills. In order to explain how this pipeline works, I will now take you through all of its steps. So to begin with, of course, we needed data. And how we started is we gathered online job postings, and specifically for job title, data scientist. Some were downloaded from Kaggle, other job postings we web scraped ourselves. In total, we gathered a data set of 2,600 job postings. And then how we extracted skills from these, please note the natural tendency of employers to express their skill requirements in bullet points. So how we got started is we extracted all bullet points from the 2,600 job postings, which resulted in a data set of 21,500 skill requirements. Now, this bullet point approach, of course, has its problems. So there are two main problems that we had to deal with. Problem one, the skills and bullet points contain a lot of synonyms and abstraction levels which describe similar skills. To analyze this, we have this pre-processing step in our pipeline in which we map the skill requirements to a semantic vector space. I will tell you about that in a bit. Problem number two, of course, people put anything in bullet points. So not all bullet points in job postings are skill requirements, but a lot of them, most of them are. But this is one of the reasons why we have this removing outlier step later in the pipeline, which I will explain in more detail. So, like I mentioned on the previous slide, in order to compute distance between skills, we needed to map the skills to a semantic vector space, so that skills that are close to each other in meaning are also close to each other in the feature space. Skills that are different in meaning, like this skill over here, as compared to these skills, is also far apart from the other skills. So this is an active research field from which we evaluated a number of tried and tested techniques, which we refer in our paper, and the pre-trained models offered by the SentenceBird library, Reimers and Gurevich 2020, they proved to be the most appropriate technique for pre-processing skills into semantic vectors. Because we extracted all bullet points from the job posting dataset, you can imagine our dataset of skill requirements contains outliers which are not skills. Well, obviously, we wanted to remove these, but we also wanted to do this in an automated way in order to keep our approach repeatable and scalable. For this, we used density-based clustering of applications with noise, more commonly referred to as a DB-scan, Astor et al. 96, to identify these outliers. For DB-scan to work, we had to reduce the dimensionality of the SentenceBird vectors. For this, we used uniform manifold approximation and projection, also more commonly referred to as UMAP, McInnes et al. 2020. Now, I'm going to show you a short demonstration of how this data cleaning technique works. So here you can see our data set of 21,500 bullet points, which we needed to clean. So what we did is we took each bullet point, then pre-processed it and mapped it to a vector space, and then we used UMAP to reduce the dimensionality to two vectors, or to two dimensions. And then we had DB-scan cluster the content. So as you see here, on the outskirts, we have all these little purple dots. And here, for example, you see one of these dots, and I don't know if you can read it, but it says temporarily due to COVID-19. So obviously that is not a skill requirement, and that's the kind of stuff that we are really looking to remove. And here, for example, this I thought was quite a funny one. I know it by now where they are. Here, there's even one company who suggests that we drop by their hairdresser. So yeah, we, of course, in our work, we did this evaluation a bit more rigorously, but it turned out to be safe to say that everything DB-scan clustered in these outskirts, we could remove it because these were not skill requirements. So we will do that now, just to show you how it works. And now you can see the features in the feature space. There are other stuff that is far away from the central cluster, which contains pretty much only skills. And for these clusters, we evaluated manually whether to drop or to keep them. For example, this large green cluster over here, it has a lot of stuff on location. Here it says you live or you're willing to relocate to New York, or it says stuff like you get 26 days of vacation. So we also removed clusters like that. And then eventually our model, it looked something like this. Of course, like I said, in the work we did for the paper, we did this a bit more rigorously, but I think this visualization gives a nice overview of how we cleaned our data set and how we cleaned the data set of 21,500 bullet points into 81,800 skills. From there, in order to build a recommendation system, we needed to cluster the skills, and to extract common employers' demands, we needed to find clusters of skill requirements in the job postings. For this, we evaluated several clustering algorithms by a combination of literature research and practical experiments, and we selected k-means, McQueen et al. 1967, as the most appropriate technique. We optimized the model's hyperparameters by silhouette score. So here is another UMAP projection of the result. And now I'm going to show you this one also in a web version. And well, I might be a geek for it, but the first time we saw this visualization, it really blew our mind. I mean, to me, it looks like some kind of continent of skills. So I spent way too much time exploring it, and I wanted to take you on a quick tour, just show you a couple of these clusters. So what you see here is that the cleaned data set of skills, we took that back to the original high dimensional feature space. There we had it clustered by k-means clustering, and now each color represents one of these clusters. And you can see that these clusters describe very similar skill requirements, which are sometimes written in a completely different way. So that is really the way how we deal with these abstraction levels and synonyms in the skill requirement data. For example, here, this green cluster is all about scripting languages like Python and R. For example, here it says coding skills in Python and R is essential. And then another of these green ones, let me search one that is not too long. You have experience in Perl, Python, or another scripting language and command line usage. Then when we go to another place, for example, here, this is really an SQL database kind of cluster. So when you go here, you see all these kind of related stuff that is sometimes described in a very different way. For example, this green cluster here is about data visualization. This one talks about Power BI, Tableau, or similar. But when you go to this side, it says only good data visualization skills. So as you can see, these very similar skill requirements, which are expressed in a very different way, our model is able to pick up on that, and still it puts them together in the same cluster. So now we designed this model in such a way that it generalizes well to skills extracted from other job postings, CVs, and learning curricula. So when a new unseen skill comes in, our pipeline is able to assign it to the correct cluster. And this asset allows us to create skill recommendations. For example, if you want to become a data scientist, you can optimize your CV by learning skills from each cluster, and we can analyze your CV for which clusters are still missing from it. So to summarize, we build a pipeline that extracts, cleans, and vectorizes skills. We use a large data set of job postings to build a model that can cluster these vectorized skills. We can now use this pipeline and model to find the cluster of new input skills. This allows us to compare CVs, job postings, and learning curricula and analyze which skills are present or missing. On this asset, we build a recommendation system that we implemented in our application Skill Scanner. Using our pipeline, Skill Scanner takes in a set of skills and returns a set of reports adjusted to the user. Here's a simplified version of Skill Scanner's curriculum to market report. In this report, Skill Scanner shows which skills are present in a curriculum and how important they are to the skills required on the job market. So the importance here is in red, and in blue you see how well this skill is covered by the particular input document. So for example, this skill, mostly on machine learning, is very important to employers, but it's also already very well covered in the learning curriculum that was analyzed to create this visual. But this skill cluster, for example, is one that is missing. It's mostly on software development best practices. So a recommendation for the owner of this learning curriculum, if it is for a data scientist, would be, if you want to enhance the curriculum to better fit the needs of the job markets, we would recommend you to include a course or a lecture on software development best practices. So to retrieve some feedback, we conducted a user study for our app Skill Scanner. We recruited 108 participants who were quite evenly distributed over all three user group perspectives. In summary, the majority of our participants found Skill Scanner helpful in carrying out processes more effectively, faster, explainable, autonomous, and in a more supported manner. Here you can see two examples of the results we got of how participants perceived some of Skill Scanner's benefits. Our participants were quite agreeable to Skill Scanner's ability to accelerate processes and also its ability to improve effectivity. Now I will sum up and indicate possible future steps. So we propose a unique approach to extract and compare skills from job postings, learning curricula, and CVs. We build an automated pipeline which applies our approach. We introduce Skill Scanner, the implementation of our pipeline as an application. And potential users of our app agreed on a range of potential benefits of applying Skill Scanner in relevant processes. For future work, we only analyze jobs for job title data scientist, so consequently we recommend to expand to other domains. We designed our app in such a way that made it easy to scale in this regard. Participants agreed quite strongly on the ability of Skill Scanner to improve effectiveness in designing study programs. Consequently, we recommend to develop a report that specifically supports job coaches and study advisors. So that was it. I wish to thank you for your attention. And should you have any questions, feel free to ask now or to get back to me through the contact information below.
Thanks. That was interesting. Don't see any questions online right now, but if there's any in the room, go and either type them there on chat or unmute.
Yeah. Hi, can you hear me?
Yes.
Thanks so much for the presentation. I was just very curious about when you did the K-nearest neighbor there, that projection. What was that? The red cluster on all the way on the left side. It seems so far removed from the rest.
Oh yeah, that's nice that you asked that. I should have mentioned because I was planning to, but I forgot due to my enthusiasm, I guess. But it's all stuff related to languages. So, for example, this one has working knowledge of French or German. So that's one of the basic knowledge of the Spanish language. So that's a skill requirement group, I guess, which is also quite far apart from all the technical stuff that data scientist needs to know.
Thank you. That was very striking. And one last question: when you do skills like, for instance, modeling, right, which it could be like prescriptive analytics, predictive analytics, or descriptive analytics, do you usually cluster those together, or you would spell it out?
What we did now is we took each individual skill and modeled and made a model of all the individual skills, and then to base our recommendations on, we check how often each skill cluster is present in respective job posting data, and that's how we determine the importance. I hope that answers your question.
Yeah. So you basically spell it out. Right? You have to say descriptive analytics, predictive analytics. It's very specific, right?
Mm-hmm. Yes.
Okay. Thank you very much. Very interesting.
Thank you.
I don't know just how much work was done by hand, especially with the UMAP, where you had to go in and start setting the limits, saying here are the outliers. We don't want that information.
Yeah, I think we really strived to make it as automatic as possible. But yeah, like I showed, at some point we had to do some manual evaluation, like determining what is the appropriate number of clusters. We made kind of like a pipeline which optimized it by silhouette score, but then still we had to dive in and see, is it really appropriate to have 60 different clusters on, because you find a couple of local optima, I guess. And then we decided to keep the 31 clusters one, because otherwise it would split very quite related stuff up, which really didn't add anything to the analysis anymore.
Okay, great. Especially that outlier of data scientists to visit the hairdresser. I wonder what they're saying about our hygiene.
I didn't find anything. I read a lot of these requirements, but I haven't read anything on hygiene yet.
Yeah, that was an interesting one. It's kind of cool that I'd never thought of the relationship between employers and the educational institutions. Helping to narrow down what is they should, continue teaching, what they might stop teaching, what they should start teaching. I hadn't thought of that before. That's really neat usage of this tool.
Yeah, I think it's really, when you consider it a triangle, I think from that point on, it makes a lot of sense that the job market kind of dictates what job seekers should learn, but because of that also partly what educational institutions should teach. So, yeah.
As we're familiar with like applicant tracking systems for employers, look to narrow down job seekers, and then like jobscan.co that compares your CV against a job and saying what skills you're missing. So this one would be nice that this is going to encompass all three of those, the sides of the triangle, not just two. So
yes, that's really the goal, to support all three players involved, because then it would be a win-win-win situation.
Yep. So any other questions from the room?
I think we're good. Yep.
Awesome. Thank you so much.
All right. Thanks for having me.
Yeah, no, I found the paper mentioned on the other presenter's website, but I didn't see any links to it. Is it publicly available?
The paper?
Yeah.
Or the application?
The paper that described it.
Yeah, I guess so. I think it should be published in the, what do you call it? The conference.
So it is going to be published as part of this conference then. Okay. Perfect.
All right.
So thank you so much.
Thank you too.